Hello, in this video we're going to talk about the least squares regression equation. In the sense, we're talking about bivariate data, and if it follows a linear relationship, then how can we describe that relationship by putting a line to it? So how do we do that? Well, I would like to draw an image. So I've drawn a little scatter plot here. And how would we put a line that describes this little bivariate data set? Now I might draw a line, and I'm doing my best here. How do I know, if that's the line, how do I know that it's the best line? Well, there are certain criteria that have to be met. What we look at are these things called residuals. So imagine this little pink distance, which is the distance from an observation to the line. And every single one of these has one of these little distances. These are called residuals. Residuals. So a residual is the distance. Now it's a vertical distance. So this is a change in y values. And it's between the observed y value and I'm going to call it the predicted y value. The observed y is from the data, and the predicted y is from the line. So the best fit line is the one in which all of these little pink residuals are as small as possible. Actually, I've fibbed a little bit there. The best fit line is actually the one in which the squared residuals, when you add them all up, are as small as possible. You can maybe imagine, what if I had put a line to this data that was definitely not a good line, like this one. Boop. You would still have all these residuals, but they would all be so much bigger, right? So you can tell that that would not be the best line. And I'm going to actually delete all of those. The line that accomplishes this task is called the least squares regression line. And so the word least squares, right, because these residuals are squared, and we want the sum of these residuals to be as small as possible, or least. This least squares regression line, it's a line, right? So it follows the y equals mx plus b format. But usually when we are creating this line, so we have a number for the slope and a number for the intercept, we represent those letters a little different. So I'm actually going to, maybe I'll just cross this out. We just use a little different notation. The one that our book uses is a plus bx. This is still a line, but they've kind of wrote it in the opposite orientation. The slope would be this b slope, and the intercept would be a y intercept. One more thing on notation is we often use this line to make predictions. And so they often will put a hat on that y. So I'm going to put a little hat on you. Boop, boop. So this would be called not just the y-intercept, but the y hat intercept. So this isn't just a y value, it's the predicted y value, or maybe I should say the predicted response value. Something that I think is neat is that this line always goes through the following coordinate. If you take the average of your x values, and then you take the average of your y values, that is a point that this line will always go through. So in our little example up here, I'm not sure where that exactly would be, but maybe right around here. So that wouldn't necessarily be a piece of data, but that would be that coordinate, x bar comma y bar. Kind of neat. So how do we actually get this line? What's up there? And that's what we're going to do in the next video, is look at a particular example with a data set, and we're going to analyze this in Google Sheets. So I'll see you there.